I'm also a little pressed for time and maybe a little over-caffeinated, so I'll try to talk slow, but also try to fit all my information in. The company I work for, I'm a web developer, and the company I work for, Global Giving, is half nonprofit and half tech company. And so we have a website, and it serves many different audiences. And of course, we want to know how many people are on our site and who's there and what they're doing at any given point in time. So maybe like many of you, one of the tools we use to measure and analyze our traffic is Google Analytics. And with Google, we get a great dashboard like this. It's very information dense. You get a lot of good information about what's going on right now, but I feel it has some shortcomings when it comes to understanding the live state and an ongoing understanding of the live state of the traffic on your site. If I want to be notified, up to the minute, if I want to keep track of how my site's being used and who's there, I kind of just have to stare at this dashboard for as long as I want to do that, minutes, hours, which is not ideal. So that's the motivation I brought to this project. I wanted to ask myself whether I could build an auditory interface to my site's data and to experiment with how well that would function in communicating this data to me orally. So of course, there's a well-established field of research into this topic called sonification, and I don't pretend to be an expert. I'm very new to it. I just found out about it working on this project, so I'll let these two quotes from some experts in the field put this project into that context for you. Great, so I'm going to show you the current state of the project. And you'll want to hear it too. And if I can try and balance my voice with this. Cool, we can hear that okay. So the current version is very simple. The only encoded data is the number of visitors who are currently on the site, which means that every note that you're hearing played represents one visitor. Oh, I haven't, right. Represents one visitor on my Global Giving website right now, like this is live data. I've grouped the data into 3 groups depending on the Google Analytics goals that all those users are meeting. So anything you can measure in Google Analytics, you can set a goal for. And so I've set this up to measure the flow that's most important to me. But all of this stuff is abstract, and in a few minutes, anybody could plug in their Google Analytics credentials and listen to the live traffic on their site. So like I said, the goals, and both the goals and the instruments are editable and can be modified to suit the preferences. So anybody else in my organization can come in and say, oh, I don't care about how you've set this up. What's more important to me is application starts or newsletter signups, and by changing these radio buttons, they can change the instruments that are playing the notes that correspond to those users. And of course, we can also change the instruments themselves. Somebody pick an instrument. Bassoon. So instead of violins, in a few moments we'll hear bassoons playing that middle channel there. So maybe we'll just listen to this for a moment. Bassoon's going to come back? Yeah, there they are. Great. So what I've created is a procedurally generated song. It's theoretically infinite, and it changes to mirror the changes in the site's traffic patterns. My goal here was kind of like I alluded to at the beginning, to create something that can exist around you, something that will ambiently inform you about something you care about while not monopolizing your attention. And hopefully, I don't know, I guess I'm a little closer to the speakers, but my goal was to play it at a volume that's somewhere around the level of cognition. I don't want to play it too loud. I want it to be something that you can ignore or tune into, suiting your preferences. And I always thought it would be interesting to play it quietly in somewhere like a lobby or a lounge, a common area of the company whose data is being represented. And in that way, it would blend into the architecture and create something of a data-enabled soundtrack. That's my idea there. So I'm going to move on into some of the implementation details, and I think I'll just keep that playing in the background. Is the volume okay? Like, can you hear me and them? And super. So the scheduling algorithm, which runs every minute, starts with a call to the Google Analytics real-time API. We use their JavaScript client library to to make the query you see at the top there. And then the response that comes back is about 3/4 of a kilobyte. And that, if I can reflect on that for a moment, like when I kind of realized that, it really blew my mind. You know, once the samples from the instruments are initially loaded, this is all the network traffic that this app takes. It's less than a kilobyte per minute. And I don't have to tell anybody here, you know, we're at the Web Audio Conference, but having all of this running on the client in the browser it just struck me as really, really powerful. I think that's very cool. So I've reproduced the important part of the response there. It's this array of pairs that map the ID of the goal that's being met to the number of users who are currently meeting that goal. And so all I do is run it through this function to map it to the 3 groups represented by the 3 instruments according to the user's selections in those radio buttons we saw a minute ago. And then we take that object and send it into the scheduler, which is the main part that's composing the piece, if you want to say it that way. And then, of course, the last thing we do is to set a timeout to run this function again a minute from now. So now that we know, if you look at this object here, Group A, there's 92 people in Group A. Or that was live when I built these slides a couple days ago. And so now that I know I want the cello to play 92 notes, how do we do that? The naive approach is just to say, okay, cello, play this note 92 times. And that's not the data that you're hearing now, of course, but we can all imagine what it sounds like for a cello to play the same note every 2/3 of a second or so. It's not that engaging, it's not that interesting, and maybe more important to me, I don't think it gives you good access to the data that's being represented. It would be hard to hear a difference of 10 or 15% in this case, which we might otherwise be interested in. So instead, after trial and error, I tried a few different algorithms, and the one I settled on uses the binary encoding of the number of notes to be played. So quick math refresher, this is how binary encoding works, or this is kind of how I think about it. 92 in binary is 10111100. So you notice it has a 1 in the 64's place, and the 16's place, and the 8's place, and the 4's place. And what that tells me is that another way to represent 92 is as 64 plus 16 plus 8 plus 4. So instead of telling the cello, play 92 notes, I can say play a certain note 64 times, a second note 16 times, a third note 8 times, and a fourth note 4 times. And by the end of the minute, we will have played 92 notes like we wanted. So this is what that looks like in the UI that I came up with. A few quick things about the UI. The song is written at 64 beats per minute, kind of makes the math really easy. But the visualization is only about 1/4 of that, mostly because that's what felt like it would comfortably fit on a browser. So what you're seeing is 4 bars of music, or about 15 seconds of data, if you want to think about it that way. So the top row is going to play 64 times a minute, and the second one 16, and then 8, and then 4. And now that I have an algorithm that will schedule the right number of notes in a minute, I make one adjustment, which is that if we left it this way, then at the beginning of each minute, all of the loops would play their first note at the same time. You can see all of the darkened ones are stacked over to the left there, so they would all play right at the same time. And to avoid that, it kind of creates this unpleasant chord that also makes it hard to tell how many sounds are being played. I just create what I called an offset variable to offset the start time of the different loops. So I kind of push them to the right a little bit. And I'm pretty happy with how this is working. I think it produces a really good balance between stability and variation. For instance, all of the numbers between 64 and 127 are going to have those same eighth notes in the green bar at the top, but all of those numbers will have different combinations of the loops below. So as the song goes on, some parts stay the same and some change, which I think has a pleasing effect. So I'll go back to the demo at this point. I'm a little bit behind here, but yeah, I wanted to point out a function I added here, noting that the numbers I've been talking about so far are relatively small, and at busier times of the year for us, and if this was plugged into another company's data, they might have 10, 100, 1,000 times more data than this. So we can change the cadence that's happening, and we can change, instead of one note for each visitor, we can say one note for 10 visitors or 100 visitors or anything like that. I'm just going to restart when I do that. So I'm going to use this to tell a quick story about earlier in the year. When I was working on this, when I was building this, like I said, I was trying a few different algorithms, and one day it would be broken, and the next it would be working. And I got into this habit of listening to it while I was at work, so I could tell how it was going and get some ideas for what I could do to improve it. And there was one morning in particular that I had forgotten. We had sent a large email. We had sent a bunch of gift cards to one of our corporate partners. And so from 1 minute to the next, it was going by like this. It's 4 or 5 a.m. on the East Coast where most of our traffic is. And it's a relatively slow time right now. And then those emails started going out and people started clicking through and browsing around our site. And all of a sudden it started sounding maybe a little more like this. And my ears told me that before I realized anything else had happened. I was off working on something else and I was just kind of listening to this in the background and kind of ignoring it. And then all of a sudden I was like, whoa, like something changed. And that's when I really started getting excited about this and feeling like there was real potential here because my ears were able to tell me something that I didn't know before about our site's traffic. Let me put that back to how it was. And then, where am I? Okay. Move into my, let's see, do I have time for this? I'll say real quickly that one of the things that I want to do in the future is to consider adding more data to this. There's a lot more data available in Google Analytics, and clearly there's a lot more opportunity for accommodating those additional data dimensions in the song that you're hearing. We could change the note selection, the duration of the notes, the volume of the notes, to say nothing of all the filters and effects we could put all on the notes, which could carry data meaning. But I'm a little wary of that, of trying to encode too much data, because it might be as complicated to understand as the visualizations that I'm trying to replace. Now, I feel like you can't have a presentation and use the words infinite song and ambient music without including a Brian Eno quote, so I'll put my favorite one here as a reminder to myself to maybe the way out of that problem I've created for myself is adding additional levels of, what does he say, additional levels of listening attention without enforcing anyone in particular. I'm going to skip there's a slide here about some of the successes I think I've had, and I think I've touched on all of them already. And the last thing I'll leave you with, besides this great quote about a very like-minded project, is the power of this tool as a motivational force. We all have times when we're less than excited to be at work, but by listening to this on my headphones and reminding myself that each note I'm hearing is one person who's on the website that I'm working on with my team is really satisfying. And of course, being able to do that without interrupting the work that I'm doing, what I'm looking at, I think is even more valuable. And it's a much more empathetic experience, as Brian gets at here. It's a much more empathetic experience than just looking at the numbers on a dashboard. There's something very visceral about music that really functions very well as a constant reminder of the people on the other end of the computer that my work is supporting and enabling. And that's all I have. Thanks very much for listening. And
excellent. So the next group can come up, but go ahead and post your questions up on the Slack channel. The first one I've got for you is from Charlie Roberts. Why traditional instruments and Western harmony?
I'll answer the second part first, Western harmony, because I'm not very good at music theory, and I asked my friend who knows it better to pick some notes for me. That is something I would be interested in exploring, unburdening myself from that, if you want to say it that way, or experimenting with different harmonies. And as far as instruments, actually, I didn't have time to show it, but the first version, I basically built the scheduling algorithm that runs on the live data in order to give myself something interesting to listen to so that I could play with all of, my original goal for this was to build a synth with a bunch of knobs so that I could understand all of the components of the Web Audio API and know what effects were and what filters were and how all of that changed the sound. And so I built the algorithm to give myself something to listen to while I was twiddling those notes. And I did that part, but then I started showing it to some people. I should show, if you'll come up to me after, I can show you the first interface I had built with the synths. And everybody kind of just like, it was like looking into my brain, I felt like, because the UI was like this tremendously complicated thing with all of those sliders. I kind of liked that one better, but I think that giving you access to the classical instruments made it a little more accessible to a wider audience. That's the short answer.
And one more fairly short one. It's how long do you listen to this at any given time, and does it cause ear fatigue or annoy you after a while?
Like I said, yeah, no, it's a great question. I've listened to it for many hours at a spell, definitely for 2 or 3 hours at a time. I'm interested in long music. I'm interested in experimental music. You know, my friends always joke that like I'm not the one you want to give the aux cord to at a party, because like I'll just put something on that just kills the dance floor and the mood. So like my taste, you guys tell me, like I want you to try it out and see how long you can listen to it. I think it's pretty pleasing. And what I was saying about the balance between stability and variation, like there's components of the song that stay the same from minute to minute, and there's components that change from minute to minute. So in that way, I think it stays interesting over longer periods of time. Thank you very much.